Hi friends, this is Chapter 7, Lesson 6. Go ahead and work your way through these two problems here and check your answers when you're done. Okay, should have gotten something like this. I know you don't have dot paper, but you can always give it your best shot. Go ahead and move on here. We're going to take a look this lesson at three-dimensional figures and just learn how to name the different parts of a three-dimensional figure: bases, faces, edges, vertices, all those types of things. So a little bit of vocab that we need to do. When we talk about a prism, we talk about a three-dimensional figure that has at least two parallel faces or bases. And the prism will be named based on what those bases are. Like, so if the bases are pentagon, then it will be a pentagonal prism. If the bases are triangles, it will be a triangular prism. We'll see a little bit more about that. Now, bases, something important to know with a base. Bases are when two faces are congruent and opposite each other. So they're congruent and they're parallel. They don't touch. Now, there's one exception to that, and that is when we get to the pyramid. Pyramid only has one base that has a vertice that's opposite from it. But most all other three-dimensional figures will have two congruent parallel bases. For something to be a plane, you're basically just thinking in terms of one set of points that are all just in the same area. So if you think of like a sheet of paper, that would be considered like a plane. If you think of one side of an object, that's a plane. If things are coplanar, it means that they exist on the same plane. So if I have, let's say, this three-dimensional figure here, you'll find out that I'm exceptional at drawing three-dimensional figures. So let's say I'm talking about this plane right here. If I put 1, 2, 3, those three dots are considered to be coplanar because they are on the same plane. Obviously parallel, a polyhedron is just a three-dimensional shape with multiple sides. Skew lines. Skew lines are lines that are not parallel and they do not cross. Okay, so like let's say we take this line right here, that edge of this three-dimensional figure, and then you see that guy right there, this line right here. In reality, on that three-dimensional figure, those lines are not parallel and they will never cross. A face is obviously any plane of a three-dimensional figure. A vertex is a point on any three-dimensional figure. And then I think that's fairly good enough. So let's move on. Okay, let's identify this figure. We're going to name the bases, faces, edges, and vertices. Okay, so we see first of all that the figure has two parallel congruent bases that are triangles. We see a base here and we see a base here. Now, why don't I consider, let's say, plane A, B, C, F? Why don't I consider that to be a base? Well, it doesn't have a parallel congruent partner. There are two triangles that are both the same size and they are parallel from each other. So those are going to be considered our bases. And we also know that since there's two of them, this is also a prism. So we're going to name this a triangular prism. A triangular prism. Triangular because it's got triangles for bases. Prism because there are two of them that are joined with parallel edges like this. Okay, fairly simple. Now with the naming, we're just going to name the bases a lot like what we named triangles. So we'll name this base A, B, E, and the other base F, C, D. Now, just something that's important about bases is that they always come in pairs. You're always going to name bases in pairs. Why? Because bases are almost always going to be matched up because they are parallel and congruent with another face. Okay, now what are the faces? Faces include the bases and all the other faces. Okay, so we see these two, the bases get included, but then we add in the B, C, D, E, which is this. Here, let me draw that better. Which is this face right here. We have F, A, E, D, F, A, E, D, and we have A, B, C, F, A, B, C, F back there. Okay, so just work your way, take your time. Make sure you take your time when you're naming those bases and faces. Work your way around three-dimensional object. Try and like picture it in your mind and turn it around in your mind to see. Make sure you get all of the bases and faces. And then the edges. These are just the lines that make up the three-dimensional figure. So we have A and B. We have B and E. We have E and A. Notice they're just going to go around and get all the bases first. F and C, C and D, D and F. Now we got the bases covered. What about after that? B and C, E and D, and A and F. And we got all the edges. Okay, vertices, easy enough. A, B, C, D, E, and F are our vertices, all the points. Okay, so basically, when we're naming these parts of these three-dimensional figures, the trick is just to take your time and be as thorough as you can. Okay, go ahead and work your way on this one. Check your answer when you're done. Okay, so this is an octagonal prism. Octagonal prism, notice it has two bases that are parallel and congruent. Now, you might say, well, there are quite a few bases that are parallel and congruent. In fact, all these little dudes are parallel from each other. Yeah, that's true. However, what would we do with the other bases when there really are two main bases that are then just connected by a bunch of other parallel planes? So it's better to name it by the most obvious pair of bases. So you name the bases, obviously, and this might get a little confusing, but do your best. A, B, C, D, E, F, G, H is the one, and then I, J, K, L, M, N, O, P is the other one. And then the faces, obviously, you see the two bases are included, and then you work your way around that octagonal prism to name all of these little rectangles. Yes, I know it's going to take some time. But we want to be thorough, okay? Show me that you can be thorough, and we won't have any problems, okay? The edges, obviously, you want to start naming just the edges on the bases, okay? Do that, name the edges of the bases, and then name all of the edges from there that connect the bases. So start by naming the edges of the bases, and then move to naming the edges that connect the bases. And then the vertices, obviously, are all the points. Okay, so let's identify the figure. We'll name the bases, faces, edges, and vertices, and then we're going to identify a pair of skew lines. Okay, so the figure has one base. All right, this is one of those rare cases where we only have one base, and that base is a pentagon. So it is a pentagonal pyramid. Okay, a pyramid only has one base. Whatever the shape of that base is what we will name it. So it is a pentagonal pyramid. What is the base? The base is RSTUV. Right, that is a pentagon. The faces, we obviously start with our base. Notice that gets carried right over. Don't forget that. And then name each of the triangles that make up the other faces of this pyramid. Okay, the edges then, you walk your way around the base first. Make sure, I know they don't do it in that order here, but I'm gonna have you do it that way so that you don't miss any. So walk your way around the base first, and then get the connecting edges after that, and then the vertices. Obviously, all the points. Now, the pair of skew lines. What about those? Well, remember, skew lines are two lines that are not parallel and they will never cross. So let's just think TS, okay, line TS and QV. Those lines are not parallel and they will never cross. So those would be considered skew lines. Okay, now you go ahead and work your way through this one. Check your answers when you're done. Okay, you should have gotten a rectangular pyramid. Now, you might ask, how do I know that this was rectangular? Well, it doesn't show you the little dots behind. However, you can fairly well assume that if there's going to be 1, 2, 3, 4 base points, that it is going to be a rectangle. So the base would be RSTU. The faces, again, start with the base and then get the other faces after that. All the edges, all the vertices. Okay, let's identify the figure, this one here, and keep moving on. So the figure has a rectangular bases. Notice, it has rectangular bases that are parallel and congruent, so it's a rectangular prism. Now, which one do we want to pick? Well, this is one of those cases where we could pick any of the pairs of bases that are congruent and parallel, and we would call them our bases. So you might say A, B, C, D, and E, F, G, H are my bases. Or you might say A, E, H, D, and B, F, G, C are my bases. Or maybe you would even say D, C, G, H, and A, B, F, E are my bases. Either way, it is safe to call this a rectangular prism. However, you need to name all the options. Okay, so match up those bases, show me that you know which faces are parallel and congruent, put them into pairs like they do here, and then name it from there. So it's a rectangular prism. Then you move all the bases into faces. In this case, they're all going to be the same. And then work your way around the edges. Again, start with whatever you name to be bases, and then any connecting lines after that, and then obviously the vertices. A pair of skew lines, in this case, we could say AE and FG. They are not parallel and they will never meet. Okay, let's identify this figure, then name the bases, faces, edges, and vertices. Okay, this is a cone. A cone has a circle base. We're going to just call it C because there are no other faces. Notice there are no faces because there's no there are no polygon shapes that are flat. Okay, it's a circle. There are no edges either because there are no straight lines on this shape whatsoever, and there's one vertex, and that is B. Now, when we talk about cross sections, the best example I can remember, and I don't know if you remember this game, but it was called Fruit Ninja, and that was where there was you would just kind of swipe at random fruit that would be thrown up in the air, and then you would cut it in half with a sword, and it would chop it in two. Well, cross sections are kind of like playing Fruit Ninja with three-dimensional figures. Okay, so if you imagine a square pyramid, okay, so it's a square base, and then you take the triangles to meet on a vertice, and imagine just taking that green, we'll call it a sword, and we're just going to slice right down the center. In a vertical slice, you're going straight up and down. What is the cross section going to be? So what is the shape going to be that you see once you make that cut? Okay, in this case, if you cut straight down on a three-dimensional figure, that cross section is going to be a triangle. Okay, we'll do a little bit of practice with this in class when we work through this together. But just imagine in your mind, if I just take a knife and cut this shape right down the middle, what shape am I going to get? Okay, now they're going to say it in a couple different ways. So what if you take an angled slice at this thing? What shape would it be? Now, remember when you think of an angled slice, you should think, okay, what's the base? Okay, in this case, the base was a square. So if I took, let's move on to a horizontal slice, that means that I'm going to do a slice that is exactly parallel with the base. Okay, so a horizontal slice is exactly parallel with the base, which means that that shape is going to be whatever the base's shape is. Okay, now if you take an angled slice of this, what you got to realize is further up the pyramid, you've got two points here that are going to be closer together than these 2 points. Okay, these 2 points are further up the pyramid. The further up you go, the further those 2 points are going to get. So we've got 2 points that are closer and 2 points that are further. So if I make 2 points that are close and 2 points that are farther, and I connect those, then that's going to be a trapezoid. Okay, so the angled slice is a bit tricky, but you need to think, what is my base shape, and how has that changed depending on where I'm at in the particular figure. All right, so go ahead and just imagine this. I gave you the answers here. Just imagine your way around this. Okay, if you take a vertical, an angled, and a horizontal slice at this thing. Okay, so imagine I went vertical slice. Okay, we would end up with some sort of a rectangle. No matter where you're going, you're going to have a point here, a point here, a point here, and a point here. And then if I connect those points, it's going to make a rectangle. Okay, now imagine if I came at it like this. Right, I'm going to end up with like a point here, a point here, a point here, and a point here. Okay, and notice I'm on a triangle, so as I move closer to this side, those points are going to get closer. Okay, so these 2 points right here are closer than these 2 points are going to be. So I can imagine, again, that shape being like that. And then if I take a horizontal slice right through that way, we're going to see, obviously, a representation of whatever my bases are here, which are triangles. Okay, well, we've learned how to identify three-dimensional figures and what it's like to take a chop right through them and see what shape you would get.